Hello everybody, welcome back. In today's video of 10-minute series, we'll be learning and understanding about wind power plant. So if you ever wondered how does electricity get generated from wind, here is your go-to answer. So first let's learn to draw how it works, because I'm also doing this for exam purposes. So let's learn how to draw it as well. First, I'm just drawing an average diagram, not something too artistic. This is a tower whose minimum height should be or can be 40 meters, even higher, 40 meter to 120 meter plus heights is also there, but I'm just telling minimum 40 meter better, so that the wind speed is affected well here. Then you have something known as your nacelle. I will explain the parts in detail, but just before that, you have gearbox, and you have brake system, you have generator, and then here is your main hub, which has the blades I have not drawn very well. Okay, the blades are not drawn very well, but kindly manage, okay? I'm not that great at drawing. In real, they don't look like this at all, but just for now, for the sake of it, I have drawn. Let me just try once again. I won't waste much of the time. Okay, so let's move on. I'll quickly label the parts. These are the blades. This is hub around which the blades are present. This entire thing is known as nacelle, and the blades are of airfoil shape. This is the tower. One more part I have missed, that here there's a step up transformer. This is the generator. This is brake. This is gearbox, and one yaw also is present between the tower and the nacelle, which I'll tell you about while explaining. So let me quickly begin with the explanation now. Okay, so first listen to what I'm saying. Wind is blowing, and there's a speed of wind also. The wind speed should be 15 km per hour to 45 km per hour. Less than this, wind and electricity cannot be generated efficiently from wind. More than this will also cause damage to the blades. Okay, it should be 15 km to 45 km per hour, most preferably. Now this wind will have kinetic energy. So kinetic energy is coming. This wind hits the blade, which causes the blades to rotate. The blades will rotate. Okay, wind energy, which has kinetic energy, this will cause the blades to rotate, which will cause the shaft to rotate. There's a part called shaft. It will cause the shaft to rotate. Okay, when the shaft rotates, it's going to produce mechanical energy. Mechanical energy is transmitted now. The rotation of the shaft will actually induce the rotation of gear motor. Rotation of generator. I'm very sorry. Rotation of generator. My bad. Rotation of generator. So the wind will hit the blades rotate, the shaft rotate. The rotation of the shaft will cause the rotation of the generator. The generator has power rotator, so basically it will help in the rotation of the generator. So this generator which is there, it is synchronous generator. This synchronous generator, basically first of all, generator converts mechanical energy to electrical energy. Synchronous generator will specifically convert mechanical energy to 3-phase power supply output. 3-phase AC supply is only going to be the output. Okay. Then you might have noticed I have not explained gearbox in brake. So let me explain that. The function of the gearbox is gearbox will increase the rotation speed of the blades, of the shaft. Rotation speed of the shaft. And the brake which is there, if the wind speed is more than 45 km per hour, I told you it might damage the blades. So it will help in maintaining the speed of the blades and reduce the speed of blades if it's too much. Okay. Then I told you there's a part called as yaw. Okay, first let me finish this. 3-phase AC power supply is generated, right, from the generator. That will go to the step-up transformer. In the step-up transformer, what happens? Obviously, the voltage is increased for transmission, and like this, power supplies from various step-up transformers connected together, and it is given to the grid lines or transmission lines, and so power is generated. Correct. Now let me speak about yaw. Now what if the now the windmill is facing this side? What if the wind is coming from this side? Right? What if the wind is coming from this side? So between tower and nacelle, you have a thing known as a part known as yaw, which will help in turning the nacelle. Basically turn the blades, which helps turn blades towards wind direction, because that's how the wind will hit the blades, that's how shaft will rotate, that's how mechanical energy is produced, that's how generator will help generating an electricity, synchronous generator, 3-phase power supply, that's how it's going to step up transformer, that's how power is collected together and given to the power lines and grid system. I hope you have understood this whole concept. So let me just quickly recap. So yeah, increase this gearbox will increase the speed of not of the wind. See, some people get confused that the gearbox will increase the speed of the wind. Technically, gearbox is in the nacelle. The wind is coming from this side. How did it increase the speed of the wind? Right, the speed of the wind cannot be altered, but the rotation speed of the shaft. Rotation speed of the shaft can be increased. So wind energy, basically the total sum up is what? Kinetic energy is there. That is getting converted to mechanical energy by what? By the rotation of the shaft, or the output is mechanical energy. The mechanical energy given to the generator, you get electrical energy. The wind speed is 15 to 45 km range. Then only windmill can convert wind energy to useful electrical energy, or else we cannot rotate the shaft itself. And all the blades are held by the hub. That also I have total. The blades are held by what? By the hub. Then when blades rotate, the shafts also rotate. So when mechanical energy is produced, the gearbox will help in increasing the speed of this rotation of the shaft. If it's too much, then the brake system is to decrease the speed of the rotation. Correct? I hope I'm telling all correct things only. If any confusion is there, just let me know. The mechanical energy is converted to electrical energy by generator. What electrical energy? 3-phase AC power supply is generated. Then in the bottom of the tower, electrical energy is given to the step-up transformer from all the windmill supplies connected together and given to the grid or the power lines. So basically, kinetic energy to mechanical energy to electrical energy. Energy conversion this is the energy conversion in windmill. And the shape of the blade, I've told you, it is airfoil shape, and yaw is present between the rubber and the nacelle, which controls the direction of the blades. I mean that it helps the blades to turn in the direction of the wind, so that maximum energy conversion can take place. And the nacelle box has gearbox, brake and generator. And the advantages of it is natural, it is free of cost. But the disadvantage of this is that constant power supply may not be achieved. So that's all for today's video. I hope I've been able to explain well. So for more such videos, stay tuned and see you in the next one. Bye bye.